All right, let's go. Experiment 6. All right, so where we should begin? Page 117, right? Let's start from the beginning. Page 117. We start with what? Title, yes? First thing is title. If you don't know the title or you don't give me the title in your abstract, that would be super trouble. What's the title of experiment 6?
Spontaneity
Spontaneity?
of electrochemical cell reactions.
Okay. What's that mean? What are we talking in here? We are talking what? Spontaneity? That means what? Huh? What does that mean? That means what? It will happen by itself. It will happen no matter what. You don't need to do anything. It will happen. It just happened. You cannot stop it. Stop what? Happen what? Electrochemical cell. What's electro? What's electro? Sounds like what? Electron, electricity, by what? By chemical means. Cell, or by chemical reactions, I should say, since the reactions are there. What about cell? Cell, we are talking what? What's cell? Can you buy a cell? Spontaneity cell? What's spontaneity cell? Sounds like what? Battery, right? Yes, battery. You buy a battery, you put in, you got power. How good, how good. All right. So let's go over one by one here, the worksheet a little bit, all right? So first, task 1. So we say copper and zinc. So you always have 2 electrodes, right? So you have a cathode and anode. So you have copper and zinc. So you have copper and zinc. All right, first question is, who will oxidize, who will reduce, what's the voltage? So let's do the table first. What's the table? Table, that means already someone done the experiment and published with on the table. So that's on page 127, yes? So we have a table here. Not the only table, of course, it's not the only list of material, so it can be much more, but just a little short list. So nowadays, all the table would be in the what? Reduction format. They are in reduction. So, which of the two, I always ask, which of the two you would like to pick to make your cell, to make your battery? Which of the two? Which two you would like to pick to make your battery? Any idea? No? So, copper and zinc. That's what we have there. So you take a look at our table, how we list. We have list the E sub 0 from negative 3.05 to positive 2.87. Yes? So therefore, which of the two you like to have? Top and bottom, yes? Top and the bottom. Why? Because that will give you the most voltage, the difference. That will give you most power, yes? So therefore, if you would highlight the 5 metal we use in this experiment, so therefore you would have 5 highlight, yes? So let's go back to the copper and zinc, all right? So the copper is, of course, we are talking about copper 2. Why is copper 2? Because our solution is copper 2 ion, and zinc is also 2, all right? So we have the golden equation, E sub cell equal to E cathode minus E anode. And we want the E sub cell to be what? Positive. Why? Because it will be spontaneous. All right, so what's the copper? Copper is plus 0.34 volt. And then zinc is up there, is minus 176 volt. So if we put minus 0.76 minus plus 0.34, then we will have a negative. That means what? We cannot do that. So we will switch. So we switch. We don't have different color. So 0.34 minus 176. Are we good? So now from the table value, we know which one is cathode, which one is anode. So which one is cathode? The 0.34. Who is 0.34? That is copper. So copper metal is the cathode. Zinc is the anode. What's that mean? So we have to write out the equation. So write out the equation. So copper is cathode. Cathode is what? Reduction. Anode is what? Oxidation. So a long time ago, I learned this trick, red color cat. Red color cat and ox. So copper is reduction. That means copper is doing this. Zinc is oxidized. So that's what you need to write out for the spontaneous reaction or equation. Are we good?
Question. So is the reduction whatever's going to be positive and then the oxidized whatever's going to be a negative?
Then you are on the right position. if you come up or come out with a negative number, that means they are sitting in the wrong position.
Also, based on the table, there's like multiple, like, for like FE, there's multiple ones. Are we supposed to decide on which one we
So
use, or, like,
Fe, iron, there are many different iron, but the one we pick is iron plus two electron to the iron solid. So that is somewhere up in the almost half, that one. So the iron plus two.
Oh, so that's the only one we use.
That's the one we are using. Why? Because our solution is iron plus 2. So iron can be plus 3, plus 1, plus 2, many different iron. Got it, got it. So we have to pick the right one. Pick the one we correspond to our experiment. Yeah? So you can highlight our 5 first. Yes? We only have 5. So highlight it. So which of the 2 would give you the most voltage? Look at my hand. Look at my hand. This is my 5. Which of the 2 would be my most voltage? That would be between my tiny and thumb. Those 2 would give you the most voltage. You got me? Yes or no? Just like we just said right at the beginning, the top and bottom will give you the most voltage. Got it? Okay, so that's the table, and you can keep on doing for all 10. All right, so by the time we go to task 2, although yes, your experimental would be non-standard because we use 1 mole upon 1 molar, and you can still get a table. So iron and silver, so we got the 0.8. That is where's the silver? So silver 0.8 is down in the about a little bit below half. So that's your silver 0.8, and then your iron is minus 0.44. So same thing, you have 2 position cathode anode, and you can plug in 0.8 here and then negative 0.44. Now you get a positive number. If you would switch, so negative in front and positive the 0.8 in here, then you get a negative number. You know you're wrong, so you switch. So from here you can tell and know which one is your cathode, which one is your anode. Of course, you can do experiment and then by reading your voltmeter. Are we good? Yeah. And observation would be your data, but please be aware your voltmeter would be in millivolt. So let's check out everything in volt or everything in millivolt. Either way, don't be one is volt, one is the millivolt. All right, so let's convert everything the same unit. So you can have all your 10 combination or pair of table and then your observation. Now, of course, the last thing and worst thing I would see if you provide me negative number in here. You cannot have negative number in here. You might see negative, but you would overcome the negative by switching. We good? Yeah. Now, the KEQ, how do we calculate KEQ? All right, so KEQ, we can take a look at the equation. I'm not going to work with you, but then just point out how and what. Let's take a look at the equation. The equation is page 121, 121. Equation 2. So you can see a general equation. So the E sub cell voltage equal to E sub 0, that's standard condition, minus RT over NF natural log Q. So Q would be your quotient, and that is whatever your concentration may be in your experiment condition, product over reactant. Now, what is our product? The product is what? Your zinc ion. So that is the oxidation. So the Q really is concentration of oxidation or endo over the cathode. So oxidation, that's your zinc. So don't forget to write out all these 10 pair of equation. All right, so that's the general equation for the Q and E sub cell. But if you do it in the standard condition, so task 1, we are in standard condition, so that will become equation 3. So E sub 0 equal to 0.05916 divided by N. N is number of electrons, and log KEQ. Do we know E sub 0? Do we know E sub 0? Yes? You have E sub 0 table, you have E sub 0 observed. Which one you should use? Either one is okay. You use the table. I got it, because table, good people, that's the where you're supposed to be. You use observe, that's fair, that's your data, and that's your data. So you can use either one in equation 3, and equal to 0.05916 divided by N. What is N? N is number of electrons in copper and zinc. How many electrons we have in the weak? It's 2. All right. So divide by 2, and then log KEQ. And you can solve for KEQ that way. Okay? All right. What about error of instrument? What's error? Well, really, we would say the error, not just the instrument, but maybe, the error of the measurement between yours and the table, all right? So error would be always is the difference between your observation and something supposed. That would be the error. Okay? So that's, I can help you this much, and then follow on the task 3 and 4. I know you are going to do it today, and then just follow the worksheet in here, and then I will ask you to be on your own. So we have 2 questions for you, and make sure you answer those, and I don't go over those. If you need to, you can come ask me later in office hour or individually. Okay? Anything? Okay, thank you.